start the recording.
And what will the quiz be on?
The quiz will be on everything covered in this week. So it'll be, I think it will be including P6, 1.1, 1.2, maybe 1.3 also. A few sections we did. They're relatively simple, I think. So the quiz will be next Monday from 1 to 1:15 as usual. You just do the quiz yourself by yourself. So we don't have class on Monday. We're gonna meet on Wednesday. You just do the quiz by yourself on Monday. All right. So that's one thing. Then again, please do not leave before I take the road. If you're not sure, just ask me. And also, if anybody missed any quizzes or the test, even try to make up them early. Don't wait. Do it as soon as possible. When you're ready, you just call me, and then I can arrange it for you. And make sure website is working. Some people are still not getting ready for website, and please buy the Xcode as soon as possible, and use it. I said a few times to create an account if you didn't use Cengage or had Cengage before. And then link the account in Cengage with the account in website, and then you should be able to access website from Blackboard as before. But in case you have any technical problems with the website with Cengage, just call the Cengage technical support or go to the help session or office hours of Mr. Hawks in Cengage. Posted his link. You can remit
Can I
with
ask an
him.
honest question? Why are
Yeah.
we looking at your notes every session?
The notes. I put the notes. I put all the
I said nodes,
slides.
not notes.
What is that? Yeah, I don't get the question. Can you say it again? I thought you were talking about notes. I put all the slides in Blackboard in the content folder. You can find all of those. You can download them if that's your question. Any other questions? So as I said, the quiz on Monday will cover everything in this week. All right. If you're not sure, just watch the video. But basically, I think it includes P6, 1.1, the 1.2, maybe 1.3 today, if we can do that. Any other questions before we start the?
So you're trying to have a quiz prospectively on 4 sections and 15.
Yeah, these are relatively simple sections. So we did a little quicker than other sections, but you will
But
not
again,
get
you're trying to have 4 sections.
many questions. Okay, you will get the same amount of questions. The content included in this quiz or these 4 sections or 3 or 4 sections will be similar to the content in the other quizzes. They're not. They're just relatively simple and short. All right. Any other questions? So, please do review a little bit of the classes we did. We I didn't get any response or anything when I asked the whole class. Nobody told me even what we did last time. So I had to go back to check it. So please do pay the quiz a little bit, okay? So that we don't have to. I don't have to take time to go back to check the video myself, and then it caused some problems in the connection for my network. So we're going to start 1.2 today. Linear equations in one variable. Again, this is one thing you probably learned before, so it should not be really hard. So we're going to start from the equations and the solutions of equations. Okay. We have different types of equations. We're going to start in general for any type of equation here, and categorize the equations in three types. Okay. The first type we call it a identity. All right. Like x squared minus n equal to x plus 3 times x minus 3. That is an equation, and it is always true. Actually, if you factor x squared minus 9, you get x plus 3 and x minus 3. So this is always true for any value of x, and we call it the identity. Okay. So the first step, the next step is called a conditional equation. When you try to solve some equation like x squared minus 9 equals 0, it is factor it to x plus 3 and x minus 3 and set each factor to 0. And then you solve for it, you get two solutions. They are positive 3 and negative 3. And we call this x squared minus 9 equals 0 a conditional equation because the equation holds only for two values of x. Okay, for some values of x in general, that's a conditional equation. And then we got another equation for the third type, 2x minus 4 equal to 2x plus 1. And this is called a contradiction because this is always untrue for all values of x. If you cancel 2x on both sides, you're going to get a negative 4 equal to positive 1. And that's always false. So this equation does not hold for any value of x, and that's why it's called a contradiction. Any questions? Please ask me questions anytime if you have. Don't just skip it. Okay, if you don't have any more questions, then we go to the next page. I'm sorry, I got a little thing here. I guess probably the format of the word and the PowerPoint, not the composer. I need to do a little thing about it. So let's talk about a linear equation in one variable now. I guess everybody knows how to solve a linear equation. For example, if you want to solve the equation of 3x minus 6 equal to 0, you just move 6 to the right, so you get 3x equal to 6, and then you divide by 3 on both sides, you get x equal to 2. Okay? And then, you can solve these equations in a similar way. Sometimes you may need to do a little more work to combine like terms. Like in the second example, we got 5x plus 4 equals 3x minus 8. So you're going to group all the terms with the x on the left and the constants on the right. So you're going to get 5x minus 3x is, if you move 3x to the left, it becomes negative, and then you move 4 to the right, it also becomes a negative 1. So you can do those things at the same time, and then you get the negative 8 minus 4 on the right. So 5x minus 3x is just 2x. Negative 8 minus 4 is negative 12. And then you do about 2, you get on both sides, you get x equal to negative 6. Okay, so that's the second example. And then the next example, we need to solve an equation with more terms, and then you just handle, each part separately and then combine like terms. All right. So in the third example, we need to solve the equation of 4x times x plus 2 minus 12 equals 5 times x minus 6. Okay, so you distribute the 4 in the first part is to get the 4x plus 8. 4 times 2 is 8. And then on the right side, you got 5x minus 30 if you distribute 5. Okay. And then you just combine like terms. Okay. So on the left, 8 minus 12 is negative 4. And then you just move 5x to the left and 4 to the right and change the signs of them. So you got 4x minus 5 on the left and negative 30 plus 4 on the right. 4x minus 5 is just the negative x. Okay. And negative 30 plus 4 is 26. So at the end, you get the negative x equal to negative 26. And then you multiply negative 1, you get x equal to 26 as the solution. Any questions for this example? Okay, and the next example is called the right equation that to linear equations. There are still linear equations, but there are rationals. You got fractions. Okay, one of the things people are always scared a lot of times, for most of students, is fractions. Okay, there is always a procedure to solve equations with fractions. The first step is always to find the least common denominator. Okay. So in this example, how do we find the least common denominator? You need to check all the denominators. In this example, we have 2 denominators, 3 and 4. So this least common denominator is simply 3 times 4 because they don't have any factor in common. Okay. So multiply 3 by 4, you get 12. So then what you do, just multiply the least common denominator on both sides of the equation or distribute. All right. Or you can just rewrite each term on the left by using the least common denominator. You can do it in both ways. And so if we do the second way as I said, then you just multiply the first term x over 3 on the left by 4 over 4 to make 12 in the denominator, and you don't change the problem. Similarly, you multiply 3 by 3 in the second term on the left, 3x over 4 to make 12 in the denominator, and you don't change the problem. Okay. So then you 4x minus 12 plus 9x over 12 on the left, and then you can combine those two terms since you have the common denominator 12. So you get 13x over 12 equal to 2, and then you just divide it by 13 over 12 on both sides to solve the equation. So when you divide by fraction, you just flip it and multiply that. So you got 2 times 12 over 13 if you flip the fraction in the denominator. Okay, and then you just multiply 2 by 12, we got 24. Then the denominator is just still 13. So that's the answer for the rational equation, you call it. So be careful about fractions, because It's easy to make mistakes, and people usually get a lot of confusion about the equations with fractions. I think we spent quite some time before talking about the fractions. Just do the practice of the parables. Okay. Any questions for this problem? Okay. The next example, we still rational equations that lead to linear equations. This time, okay, we get the variable in the denominator, not just the numbers like in the previous example. So we got 3x over x minus 4 on the left, and on the right we get 5 plus 12 over x minus 4. So we get two terms with the same denominator, x minus 4, but they include a variable. That's the difference between this example and the previous one. So this makes a little easier for us because we got the same denominator, and we don't have to find the least common denominator, all right? So we can combine those two terms with the same denominator with x minus 4 on the left. So we just put the term of 12 over x minus 4 right to the left. That's how it becomes negative. Now, since we got the same denominator x minus 4 on the left, we can just combine the numerator to get 3x minus 12. And the denominator is still x minus 4. And then you're left with 5 on the right. Okay, then you can factor 3 on the top from the two terms, and then you get x minus 4. Okay, and this x minus 4 will be cancelled with the denominator x minus 4. So you're going to get 3 on the left, but on the right you still have 5. So we got something false. 3 to 5. So that means the equation is invalid, or we got a contradiction. So this problem has no solution, right? So this is the example of contradiction that no value of x can satisfy the equation. The equation itself is wrong, okay? Any questions about this example? Okay, okay, the next topic is how to find the intercepts algebraically. You know, intercepts or the intersections of the curve with x and y axis, as we talked about before in the previous section. And we have recognized the intercepts from the graph before, but we can also find the intercepts algebraically. So how do you do that? Okay, for example, how do you find the x and y intercepts of the graph of each equation algebraically? Here's the example, equation y equal to 4x plus 1. How do you find the x, y intercepts? Okay, very simple. To find the x intercept, you set y equal to 0 and solve for x. So if you let y equal to 0, and then you get 0 on the left, and you just solve the equation of 0 equal to 4x plus 1. So you can, 1 to the other side to get -1. So the equation becomes 4x equal to -1. You just divide by 4, you get the x equal to -1/4. So that's the x intercept. And to find the y-intercept, you just do the opposite. You set x equal to 0 and solve for 1. And this time it's even more simpler. If you set x equal to 0, then the equation becomes y equal to 4 times 0 plus 1. And 4 times 0 is 0, so you get the 0 plus 1 with 1. So that's the y-intercept. All right. Let's do another example, 3x plus 2y equal to 6. How do you find the x, y intercepts? Again, you set the x equal to 0 and solve for y to get y-intercept and set y equal to 0 to solve for x to get x-intercept. You can do either one first. If you do the x-interceptors, you just set y equal to 0 in the equation. So you get the 3x plus 2 times 0 equal to 6. 2 times 0 is 0, so 3x plus 0 is just 3x. So the equation becomes 3x equal to 0, and then you divide by 3 on both sides of the equation, you get x equal to 2. So that's the x-intercept. Similarly, to find the y-intercept, you set x equal to 0 and solve for y. So if you do that, the equation becomes 3 times 0 plus 2y equal to 6. And 3 times 0 is 0. So 0 plus 2y is just 2y. So the equation becomes 2y equal to 6. And just divide by 2 on both sides of the equation. You get the y equal to 3. So that's the y-intercept for this graph of the equation. So that's the 1.2. Very simple, I think. Any questions? Okay, please ask me questions if you have any. Otherwise, if you don't, then I will assume you don't have any questions. I just go forward. All right. So we, sometimes we do things a little slow, but sometimes it will be a little faster if you don't have any questions and the content are relatively simple. All right. So that's 1.2. So we're done with 1.2. So let's just start at 1.3 now. Okay, let me upload the slides for 1.3. And just wait a few seconds for the slides to up down and to upload it. Okay, 1.3. All right. So, okay, 1.3 may take a little more time. It's the modeling with the linear equations. So, what does that mean? We're going to use linear equations to solve real-world problems, basically. And there's always a standard procedure or steps to solve real-world problems using mathematical models. You're going to do a verbal description of the problem to start, or you are given the problem, okay? And then you need to write a verbal model, okay? You need to write some equations in words. That's called a verbal model. And then you translate this verbal model into algebraic equation. All right. And there is one thing that is actually critical is to assign a variable for the question asked. Okay. So let's just do the examples one by one to see how we do solve practical problems or word problems. Okay, in this example, it is you accept the job with the annual income of $32,300. So that's the annual income of the job. And this includes your salary and the year-end bonus of 500. So that includes the salary and the bonus at the end of the year. Yeah, and you are paid twice a month. So the question is, what is your gross pay for each paycheck? Pay before tax. Okay, gross pay. All right, so you got $32,300, and that includes the salary and the bonus of $500. So then you need to build the verbal model to start. Okay, so the total income for the year is the salary plus the bonus, and because you paid twice a month, so that means you're going to be paid 24 times for the whole year. You got the 12 months for a year, so that'll be 24 paychecks, and then the amount of each check which is asked in this problem times that, so you get the salary plus the bonus like this. So let's just assume X to be the amount of each paycheck before tax. So the income for the whole year is 32,300 on the left. That'll be equal to 24 times X plus 500 if you plug in as numbers and the variable into the verbal model or equation. Then you get this equation, and then that's easy to solve. So that's not a hard problem. Okay, just move 500 to the left, it becomes negative. So you can subtract 32,300 and the 500, you got 31,800. And on the right hand side, just got 24x. So to solve this equation, you just divide by 24 at the end to get $1,325 per paycheck. Okay. Any questions? So that's the standard procedure to solve practical problems. You write a verbal model, and then plug in the numbers and the variables in this verbal model and solve the equation. So the verbal model is basically the idea in your mind, actually. So we just write the ideas in your mind into words, right? So that's the first example. Let's do some examples. In example 2, it's about stock, okay? So you buy a stock at $15 per share, and you sell the stock at $15 per share. So the question is, what is the percent increase of the stock's value? Okay, so this problem looks pretty simple, but a lot of people will get wrong. Okay, so we need to find the percent increase of the stock's value from the previous value. All right, when you bought it. So again, we can write the verbal model to start. So the increase in the price of the stock is equal to the percent increase of the stock's value times the old price of the stock. Okay, so that's what what's in your mind, right? Okay, so again, we just denote the percent increase of stock's value by X. All right, and then plug in numbers for the other quantities in this verbal model. So the increase in the price of the stock is just 18 minus 15. Okay, you buy it at $15 and sell it at $15. So the increase in the price will be just 18 minus 15, which is 3. And then percent increase stocks value, that's what we need to find it. So that's X. And then times the old price of the stock. Okay, that's 15. So that's how the actually how the percent increase of the stock's value is defined. This verbal model essentially tells what it means by the percent increase of the stock's value. So on the right side, you get 15x. On the left, you get 3. So you just divide by 15 on both sides to get x, which is 0.2. And if you convert that into percentages. That's just a 20%, isn't it? Okay. Any questions for this problem? Okay, let's do another one. So this time it's about the income again. It's about the cost, I think. So your family has an annual income of $57,000, and for only monthly expenses. Is that a? I think it should be S instead of C. I'm sorry, there's typo here. So in this income, you're going to pay the mortgage, which is $1,100 per month. Okay, and the car payment, you also get the car to pay the car, $375 per month, and the food $295. Those are very typical, and the utilities $240. That's normal. Credit cards $220. That's not much. Okay, so these are the expenses you have for each month. So the question is then the total value of the monthly expenses, okay, represents what percent of your family's annual income. Okay, so how much? What's the percent of the cost in the income? Okay, for each month. So again, you start from the verbal model. The monthly expenses is the percent times monthly income. So we are trying to find this income. How much is the percent of the expenses from the income. So again, we're going to let the percent to be X. Okay, and the percent of income, is the expense. So we let that to be X, and then put the other numbers in the verbal equations. So monthly expenses, including all the items. So we just had mortgage $1,100, car payment $375, food $295, utilities $240, and credit cards $220. Okay, so add all those expenses, monthly expenses, and then percentage just X. That's what we need to find. Now the monthly income is just the annual income over 12 months. So that's what it means, the income, right? So if you do that, you add those numbers on the left, you get 22,000, 2,230 on the left, and then 57,000 by 12, which is 4750, all right? So then just divide it by 4750 on both sides to get X. So if you divide 2230 over 4750, you're going to get 0.469, and that's 46.9%. Okay. So that's not much, right? So $57,000 income after tax, I'm assuming, is actually pretty big. Okay, you get a good income. So any questions about this example? Next. Okay, this time we got the geometry problem. It says a rectangular family room is 3 times as long as it is wide. Okay, so you have room which is a rectangular shape, of course, and the length is 3 times the width. Okay, and the perimeter is the 112 feet, the total length of the full size. And then we need to find the dimensions of the family room. So again, the verbal model, this time it's the formatter in words. It says 2 times the length of the rectangle plus 2 times the width of the rectangle is equal to the perimeter. Of course, in a rectangle, you have 2 lengths and 2 widths. So this is the verbal model, and then you just translate this word equation into a math equation. So again, you need to assign a variable for the quantity you want to find. So in this example, you can either assign the variable to be the length or the width of the room. Let's just assign the variable x to be the width of the rectangle. Then the length is 3 times as long as it is wide. Okay, so the length will be 3x, right? If the width is x, then the length will be 3x. So the equation becomes 2 times 3x plus 2 times x equal to 112. And 2 times 3x is just 6x, and you just add 2x, you get 8x. So, and then you get 112 on the right, so just divide by 8 to get the x, solve the equation. 112 by 8 is 14, so that's the width. So the room is 14 feet wide, and the length is just 3x. It's 3 times the width. So 3x, 3 times 14, you get 42. 42 feet for the length. So that's the dimension of this room. All right. Any questions? No. We just go to the next problem. All right. Okay. Let's talk about a travel problem this time. It's a plane is flying non-stop from Portland in Oregon to Atlanta in Georgia. And the distance from Portland to Atlanta is about 2170 miles. Okay. So it will take a few hours. So after 3 hours in the air, the plane flies over Topeka in Kansas. Kansas. Oh, there should be A instead of U, right? So from Portland to Topeka is Topeka is about 1,440 miles. Okay, and it takes 3 hours. So assuming the plane flies at a constant speed, how long will the entire trip take? Okay, so in this problem, the verbal model will be distance equals rate times time. Okay, or the speed times time. So we know the total distance between Portland to Atlanta, and we need to find how long it takes for the whole trip. And we know it takes 3 hours from Portland to Topeka. And so then we can use that to find the rate or the speed of the plane and plug in those into the verbal model. Okay, so again, let's just assume x to be the time for the entire trip, and that's what we need to find. That's always the case. Okay, in real world problems, what is asked is usually to be assigned the variable. Okay, and that's how you start the problem actually. Okay, so then what? So the total distance between Portland to Georgia is 2170. So that's on the left, and the rate, okay, the rate is just 1440 over 3. Okay, it takes 3 hours from Topeka to from Portland to Topeka, which is 1440 miles. Okay, so the rate will be just the distance per time. Okay, so we use the verbal model again in here. So that's how you find the speed, right? Okay, and then times x, the total time, or the entire time. So 1440 over 3 is 480. So you got 2070 equals 480 times x. And then you just divide by 480 on both sides. You get x equal to 2070 over 480, and that would be about 4.52 hours. So that's almost 5 hours. That's about right. Okay. For example, if you fly from Huntsville to I don't know, to San Francisco. I don't know if there's a straight A or not, it's flat or not, but usually you take about 5 to 6 hours. That's about right. Okay, so I guess I'm going to stop here. We got 2 more minutes. I don't think I want to rush to another problem. So we didn't finish. We don't finish 1.3 today. We're going to continue next time. So the quiz will include the sections P.6, 1.1, and 1.2. All right. Any questions before we dismiss the class? So I guess please review the material covered in the class. So I don't have to ask you, what we did the last time. These questions. If you don't have any more questions, let me just take the roll and you can leave. All right. So I'm going to stop the recording now.